Next up is Mehdi Bendriss, Senior Software Engineer with Canonical, who is going to show you a cloud vendor agnostic alternative to deploying and operating OpenSearch in a hybrid multi-cloud scenario. And he'll show you how you can achieve this using open source charmed operators. So please put your hands together and give a warm welcome to Mehdi.
Hi, everyone. So I'm Mehdi. I'm happy to be here. I'm a software engineer at Canonical, working on the data platform team and focusing mainly on OpenSearch. So before diving into the core subject of the talk, I wanted to quickly go over the agenda of what I'm going to cover. So first, we're going to cover a few definitions of terms that we'll be using all along the talk. And then we'll talk briefly about the tools and frameworks that we actually use. And what is it we're building for OpenSearch, the main architectural components of the things that we are building, and finally, the way that we are planning to distribute OpenSearch. And finally, to close down, we'll share channels that we want to share with the community to stay in touch with us and reach out to us. So many people know Canonical as the company behind Ubuntu. While it's true, we actually do many other things. We tackle a wide range of problems and solutions, and one of particular interest for this conference is actually charmed operators. So the data platform team I'm working on focuses on data solutions, ranging from RDBMS, such as Postgres or MySQL, to NoSQL databases or cache layers, such as MongoDB or Redis, to processing and ingestion engines such as Spark and Kafka. And the products we built are cloud agnostic and able to run on any cloud substrate, ranging from VMs to machines to Kubernetes environments. Traditionally, developers and operations were two separate as you all know, disciplines and workflows, and that we try to get together and incorporate into parts of the normal workflow of software development, right? Except when it comes to managing and administrating distributed applications, things get hard, right? So we divert a lot of time and efforts from developers to actually manage the operations of such applications, right? So charmed operators are essentially here to work around this and reduce the strain that we put on developers for managing such applications. I want to define what a charmed operator is. So essentially, a charmed operator is really the application domain knowledge of a specialist distilled into clean and tested code and then packaged to be able to run in any cloud substrate, with the slight exception of Kubernetes that requires some slight adjustments from the charm developer, but essentially gives the end user the same user experience and the same tools to run the charm, right? So in this case, the application that we are referring to is actually OpenSearch, right? So now, given the nature of OpenSearch and many of the applications used in the enterprise today that are OpenSearch, we think that it's no longer the problem about getting one's hand on the software or its license, but rather how to operate such a software in a robust but easy manner. And this is really where we think that we could make this easier by open sourcing the operations code to manage such software. So to kind of summarize this into a simple definition, a charmed operator is essentially operations code packaged. So charms are supposed to assist us with various lifecycle of an applications, right? And an application goes through a number of stages, such as installation, configuration changes, scaling up, scaling down, and so on and so forth. Then charm developers should be able to expose actions that are operations for administrators or software engineers that will actually run those charms and manage those charms. And those actions can be anything from a backup to snapshotting to resetting password or certificate renewal or whatever, you name it, that the charm developer actually chooses to expose to its users. And then through the definition of relations, the charm developer actually opens integration capabilities to the application they wrote the charm for. So a charm developer can choose to write an integration between two products through relations, such as opening a relation for MySQL or LDAP or whatever. Essentially, a charm developer takes ownership of the heavy lifting of figuring out how to integrate two applications. So what is it that we are actually using to build charm operators? So we use Juju. So Juju is the charmed operator framework that we use. And it allows us to deploy cloud infrastructure and manage it from day 0 to day 2 or day n, which is something that we think many applications are currently, many solutions out there are currently lacking, right? So with Juju, one can install, maintain, upgrade, you name it, their application in a various mix of cloud substrates or on-prem or public cloud environments, right? So Juju provisions machines and containers as needed. So for Juju, for Charm developers, Juju provide two main mechanisms that are of interest, right? So the Charmed Operator Lifecycle Manager, right, or OLM for short, which enables the management of an application's lifecycle, such as we defined the install or in the previous slide, or update and things like that, right? So the Juju SDK is the one that we offer to developers to actually write charm code. So I'm not sure if you're able to see the screenshot up there. I don't think so. But essentially, what the charm developer defines are callbacks for events emitted by the OLM. The charm code can be written in any programming language, really, even though we advise and we strongly suggest that people use Python, as we make it a first-class language for charm development. So what Juju is not an ISC, infrastructure as code tool, right? So while there is some overlap between the capabilities of Juju and ISC tools, they essentially operate on different layers. So it's possible to deploy applications with infrastructure as code tools, but it becomes very difficult to actually, so for example, with raw Kubernetes YAML or Helm charts or whatever, right? But it becomes very difficult to actually manage them as for complex deployment scenarios, whereas Juju is able to actually tackle those scenarios as it is built for this kind of things. So finally, infrastructure as code tools play well with Juju when it comes for specific, complement Juju and plays well with Juju when it comes to specific fine-grained operations, such as, for example, service roles or network configurations, in which case those two tools can play well together, and we offer a Juju Terraform provider for that. Our charms, Canonicals, and the community's charm are deployed in Charm Hub. We currently have hundreds of charms that the community and that Canonical has been, and that also the data platform team has been working on. And you can find more details. And if you're interested really in following our development, feel free to check the GitHub link over there. Yeah, now I wanted to actually talk about what is it we're doing for OpenSearch at Canonical. So the things that we are currently working on is we are building charmed operators for OpenSearch. And we would like to offer two charmed operators for OpenSearch. So the first one is a machine charm that is supposed to be able to run on a bare metal environment through mass metal as a service, right? VMs in such as EC2 instances or VMware or KVM in OpenStack with OpenStack, whatever, right? Or LXD containers. The second category of charms that we are going for is Kubernetes charms, KS charms, right? So we are still at the early stages of the development, so we appreciate any input from the community or suggestions. We are pretty open for that. So a nice thing to notice and to note for Kubernetes charm is that the charm is deployed as a stateful set, managing a set of pods of the charm and the application itself, right? So the charm code runs as a sidecar container of the said application. This is our initial roadmap that we're currently working on. So we would like to, for the first community version of our charm, focus on the high availability and resiliency, and mainly the replication automated failovers, scaling up, scaling down, and the security, such as certificate management, initial user and role management, and basic auth for HTTP. Our roadmap will be published in our GitHub repos, hopefully. Before coming back to OpenSearch specifically, I wanted to show how a hybrid deployment may look like. So it seems like there is some misalignment on the diagram, but yeah. So here we picked two separate clouds, AWS and an on-premise environment, right? And we would like to deploy an application, right? As we said, an application can be anything from OpenSearch to a MongoDB database to really a WordPress website, right? It doesn't really matter. Just here for the sake of space, let's call it app one. So what we essentially want to do here is deploy this application and manage it via Juju, right? On these two clouds, AWS and on-premise. So on AWS, we would like to deploy it on EC2 instances and on-premise on VMs. So the first thing that we do here is packing up the charm code, right? So for that, there is a command, a CLI that we provide, charmcraft pack, and this essentially packages our charm code, right, into a deployable file. Then afterwards, what we do is setting up the Juju controller, right? And the Juju controller is a pretty important piece in Juju deployments, as it serves as the initial instance that gets deployed in a cloud and serves as some sort of middleware between the Juju client and the cloud, right? And the model and the applications deployed. So here we are creating and bootstrapping a Juju controller, Juju Bootstrap. We can pass configurations such as the VPC ID, right, of AWS, the name of the cloud, AWS, and the name of the controller. Once done, what we do is we actually create a model here named Model 1. And a model is essentially a workspace where applications are deployed, and applications that have a relationship that work well together and that should contextually be with each other are deployed on. And finally, we deploy the application with a number of units. So here we want to have 2 instances of the application one. And if you see closely, you'll see that in each blue box, which refers to an EC2 instance, we have 2 little squares with the application one and the charm square, right? So as we said, the charm code runs as a sidecar with the application. And this is a cool thing because it means that as we scale our deployments, our charm always accompanies the application. So they essentially scale together. Of course, this was assuming that the credentials for AWS were set up and so on and so forth. Then the same goes for the OpenStack, the on-prem deployment, right? So we create a controller, an OpenStack controller with the same thing. We add a second model, and then we deploy the charm with an initial unit, and then we scale it up by adding 1 unit. we talked about how a deployment in a hybrid cloud may look like, right? Now, how does that translate more granularly at the Juju unit, which means the instance? In the case of a machine charm, it will be the EC2 instance, right? So here, what we want to do is we are looking at a simplified drill down of such a unit, right? And what we want to do is deploy a charm that would manage community plugins. So in case we wanted in our deployments to offer users a way to deploy community plugins, right? So in this case, what we do is we create a subordinate charm, right? And this is a charm that has a one-to-one relationship with the principal charm of OpenSearch. The way that this goes, so we deploy a charm, the OpenSearch charm with one unit, and this is the one, the blue one that you're seeing, right? And then we deploy a second charm, which is the subordinate charm that's supposed to take care of the tasks that we wouldn't want to give to the principal charm, in this case, the plugins charm. So we deploy one unit of said charm, and then we relate these two charms to each other. And this is a pretty cool concept, as this allows charms to integrate, to integrate with each other. For the case of subordinate charms, there is a one-to-one relationship between the two. And then we allow user to run an action on the unit number 0, which is the blue one, right? Called install plugin, which is an action that is defined by the charm developer to its to their users. And then if you notice, there is a little small database over there on the controller model. And this database is a database that people don't really have to care about, right? There is nothing to deploy there. It's automatically managed by Google. It's just a database deployed under the hood. And the good thing about this is that it's a database allowing us to actually keep track of certain things, right? So an example for this would be to store a flag, whether the security, the open distro security index had been initialized or not, right? So we could store a flag, essentially preventing the charm developer somewhere in their subsequent logic to override the said index. So all they have to do is query this database using a very simple API, right? That lets them know whether the security admin script was ran or not. What about other OpenSearch components? So let's say that for a rather large organization, we wanted to deploy the OpenSearch dashboard behind a load balancer, such as HA proxy. So how will that look like to actually give access to hundreds of analysts to Jupyter notebooks, for example? So the same principle applies. So we deploy the OpenSearch dashboard, we deploy the HA proxy charm, and then we relate these two charms with each other, which means that we create an integration between these two charms. This actually has a prerequisite that our charm, which is in this case the OpenSearch dashboard charm, has implemented a way to manage such a relation, right? But our charm should be able to function without this relation, without this integration, which means that our charm should be able to run without having a load balancer. And this is the power of those relations. So this is it's a way to integrate and augment our charms, our provided charms. So in this case, we relate these two, and then we run Juju expose HA proxy so that we allow ingress traffic to hit our load balancer, because by default, only the traffic from within a model is able to reach units. So now we expose the HA proxy, and then we scale the OpenSearch dashboard by a unit, effectively making OpenSearch dashboard load balanced. So here is the overall high-level architecture that we are currently going for. Our immediate goal is really to focus on the OpenSearch core, right? To provide what we talked about in the roadmap, essentially the first yellow box on the left. And we are thinking of providing those charms also as bundles, so that administrators or developers don't really have to care about even the 5 commands that we talked about, right? The Juju relate and so on. So packaging the charm code with the relations and all the stuff we talked about. But we really want to focus on the left part of the diagram for now. And if you notice, there is a little icon and of a bird on top of OpenSearch, right? And this refers to Snap. So this is essentially the way that we install OpenSearch in our charms. So in addition to the charm that we talked about, we are also working on providing snaps, right? So snaps are essentially programs that are packaged with all their dependencies, right, to run on all major Linux distributions, and that run in a confined with restrictive security sandbox. So we can poke holes in the security sandbox through plugs and interfaces, such as when a snap requires access to the system files or to the network, and so on and so forth. And we are working on providing a snap for OpenSearch for deployments that do not use Juju, such as, for example, simply local deployments. If someone wanted to play around with OpenSearch easily and have a one node cluster in their machine with TLS setup and those kind of actions. So we are working also on providing this kind of charm, and this is the user experience that we are going for. So the user installs cluster with TLS and certificates, self-signed certificates setup. As we grow, we would like the input of the community as to know what kind of actions we should expose and what kinds of services we should expose through this snap. So this is something we're actually looking forward to. Speaking of community, at the end of the day, we run by and for the community. So we like to stay in touch and get their feedback, get their input, get their engagement. And those are a few channels for the community to stay engaged with us and reach out to us. So we have a Mattermost server where people can actually ask questions or talk to us or just drop by to say hi. With that, thank you for being here. Michel and I, our product manager, is here. So you can reach out to us. We're pretty approachable. Thank you.